So we know that the rich diversity of the chemical behavior, it depends on the internal structures of atom of that element. So different element has different internal structures of atoms. That's why different chemical behavior of different elements. So today's learning point is number 1, the discovery of protons and neutrons and their characteristics. Thomson model of atoms. And X-ray, discovery of X-ray, how it is useful. We are aware of the X-rays because medical diagnostics, we need the X-rays. Discovery of the radioactive elements and alpha, beta and gamma rays. So we'll start one by one. Now first, the discovery of protons and neutrons. Electrical discharge carried out in a modified cathode ray tube. During the electrons, we use the cathode ray. It is a different of the cathode ray tubes because the thing is that these canal rays carrying the positive charge particles. There we have seen that from the cathode, negative charge particles are moving toward the anode. That means positive charge electrodes. You can find this in the class number 011. So in this class 012, we are describing the protons and neutrons. So these positively charged particles we can list it as the, unlike cathode rays, that means which is the electrons later is found. In this case, the positive charge, because in the cathode rays, we know that the cathode rays is independent of the mass of the gas inside the cathode tube. But in this case, the positive charged particle, it depends on the mass of the particles of the gas. That means the nature of the gas, if different, then different mass of positively charged particles will found in the cathode ray tube. These are simply the positive charged gaseous ions. The charge to mass ratio of the particle depends on the gas, what I already told, from which it originates. That means whatever the gas is there inside the cathode tube, its particle's mass depends the nature of the positively charged particle. And so the charge to mass ratio is the dependent of the nature of the gas. Third point, some of the positively charged particles carry a multiple fundamental units of electric charge. So it has some fundamental units of electric charge. When the positive charged particle is flowing through the cathode ray tube, and it is called the canal rays that time. So the behavior of these particles in the magnetic and electrical field opposite to that observed for the electron and cathode rays. In electron, whatever the observation was the behavior of this particle in respect of charge, this is the just opposite of that. We know that that time the cathode rays, nothing but the electrons, it is a negative charge. In this case, it is the positive charge. And so in the magnetic and electric field, it will behave just oppositely because charge is different. The smallest and lightest positive ion are obtained from the hydrogen, and then it is called the proton. Now we know that proton is nothing but the hydrogen atoms except electron. These positively charged particle is characterized in the year 1919. So proton is the, we usually now considered H plus. So later a need is felt for the presence of electrically neutral particles as one of the constituent of the atom. This particle was discovered by the Sedgwick in the year 1932 by bombarding the thin sheet of beryllium with alpha particle. What is alpha particle? We'll discuss later. When electrically neutral particle having a mass slightly greater than the protons were emitted, he named this part, because this is the neutral, so from there this name has come, neutrons. Now, important properties of all these fundamental particles, that means electron, proton and neutron. Now we'll discuss about the atomic model. So we got a lot of observation from the previous experiments, and from these experiments and observations, first we found that the Dalton's atoms, in the Dalton's atomic theory, the Dalton's atom has some atomic particles carrying both positive and negative charges. So now the major problem is, what is this after the discovery of this electron, proton and neutron, that how to account for the stability of atom. Because if electron and proton both are opposite charge, electron is negative and proton is positive, and if it will be together, then it will be collapsed. And then the atomic model we have to design in such a way that there is the electron and the proton and the neutron will have the separate existence. So we have to account the atom stability to consider the atomic models. Number 2, to compare the behavior of the elements in terms of both physical and chemical properties. We know that different elements has different behaviors in respect of physical and chemical properties. So how to explain from the atomic model. Third point, to explain the formation of different kinds of molecules. We know that different compound, different molecules is formed, and it is the combination of different atoms. So how to explain by using the atomic models. Number 4th point, to understand the origin and nature of the characteristics of electromagnetic radiation absorbed or emitted by atoms. We know that atoms is absorbing or emitted the electromagnetic radiation. And then what is the origin and nature of this radiation? We have to understand by using the atomic model. So these 4 models, these 4 points we have to consider when to design the atomic models, which will have the both electron, proton and neutron subatomic particle in atom. So different atomic models was proposed, and out of that first proposal, J.J. Thomson is proposed one model. Now it is the obsolete, and later the Rutherford atomic model were introduced. So today we'll discuss only the Thomson's atomic model, and in the next class we'll discuss about the Rutherford's model. Thomson's, you see the figure. In figure, it is said that the radius of this watermelon-like structure, its radius is the 10 to the power minus 10 meter. And it is said that positively charged is uniformly distributed according to the Thomson model of atoms. Then electron is embedded into it. in such a manner as to give the most stable electrostatic arrangement. So, if you consider this model, then so many types of natural model you can consider, and watermelon, that type of concept also there. And this model visualized as a watermelon of positive charge with seeds, which is considered electron embedded into it. Now, how do we explain these 5 points? Whatever we discussed that to get the right model of atoms. So in this Thomson model of atoms, an important feature of the model is that the mass of the atom is assumed to be uniformly distributed over the atom. This is the point number 1 from the Thomson model of atoms. Second point, although this model is able to explain the overall neutrality of the atom, but it is not consistent with the result of the later experiment. Whatever experiment is done later, mainly by the Rutherford, then we'll explain in the next class, class number 013. So Thomson was awarded Nobel Prize for the Physics in the year 1906 for his theoretical and experimental investigation of on the conduction of electricity by gases. Now we will consider the X-rays. What is the origin? And you know all, this is the history. In the year 1895, the scientist Röntgen discovered this using the cathode ray tubes. You can see here, that time he used this tube. This is the scientist. So then he found some rays, and it is called, that time it is unknown about that rays, so he simply named this the X-ray. Till now we are considering the name X-rays also, and here you can see the model, and with this model you see the anode is there, cathode is there, and from there the cathode, if particle is moved, if tungsten anode is there here, then it will reflect from there, it will come outside as a X-ray beam. This is called the X-ray beam. So it was noticed that the X-ray is produced effectively when electrons strike the dense metal anode called target. So this is the target. So if that target, that from the cathode electrons beam is moving, and if it strike there, then one different type of beam is coming, which is called the X-ray. These are not deflected by electric and magnetic field. Whatever the X-ray we now called, this is not that deflected by the electric and magnetic field and have very high penetrating power through the matter. And that is the reason why these rays are used to the study of the interior of the object. And these rays are of very short length. That means approximately 0.1 nanometer and possess electromagnetic character. Now we'll discuss about the radioactive elements, the discovery of the radioactive elements. So you can see that the scientists observed that there are certain elements which emit the radiation on their own, and name this phenomena is the radioactivity, and the elements are known as the radioactive elements. This has the totally separate chapter. When we'll discuss that chapter, then we'll discuss it in details. Here only the history of the discovery of the radioactive elements. This field is extremely developed. This field is extensively developed by the Madame Curie and Marie Curie, Rutherford, Frederick, so deep. It was observed that the three kinds of rays, that means alpha rays, beta rays and gamma rays, was emitted, and Rutherford found the alpha rays consist of the high energy particle carrying 2 units of positive charge and 4 units of the atomic mass. We'll discuss details when we'll discuss the Rutherford model in the next class. So with this experiment, whatever the conclusion is there, the alpha particle are helium nuclei, as when alpha particles combined with 2 electrons yielded helium gas. The beta rays are negatively charged particles similar to electrons. And the gamma rays are high energy radiation like X-rays, and it is neutral in nature and it doesn't have any particles. As regard to the penetrating power, alpha particle has very less. It has the least penetrating power. And then the beta particle has 100 times more penetrating power than the alpha particles. But gamma rays is the almost 1000 times of that of the alpha particles. So gamma rays has greatest penetrating power in respect of alpha particles, beta rays and gamma rays.